Welcome to Train Signal. I'm Mel Haynes, and in this video we'll be looking at database mirroring in SQL Server 2008. But jumping into our overview, the first thing I want to do is a mirroring overview. Just talk a little bit about mirroring, what it has to offer. Then we'll get into some of the operating modes available with mirroring. There are various roles that SQL Server can play in a mirroring paradigm. We'll look at those. The mirroring service account, we'll talk about what Windows account to use, how you can use it, and things of that nature. We'll get into mirroring sessions. We'll talk about what a session is and what benefit it buys you when you're looking at mirroring. We'll look at endpoints. Endpoints allow you to communicate one server to another, and you'll have a specific endpoint used for mirroring. And then switching roles. We talked about the roles that SQL Server can play, but in many cases, the reason for mirroring is you want to be able to switch between those roles, sometimes automatically, sometimes manually. We'll look at that. And then last, I want to look at some recommendations for mirroring, as well as some restrictions you will likely encounter when you go to implement mirroring. Jumping into our mirroring overview. First of all, why do we want to use mirroring? What does it do for me? The first thing is data protection. Mirroring will allow you to keep a second copy of your data that's quickly available on a second server. So database mirroring, to use some of Microsoft's own words, provides complete or almost complete, depending on how you have it configured, redundancy of the data depending on whether the operating mode is high safety or high performance, which basically equates to synchronous versus asynchronous communication with the mirror. Second, increases availability. So in the event of a disaster, bringing your server back up will hopefully be a much faster process. You actually even have a choice of automatic failover, so that your client applications will be completely unaware of the change. Now, there's a lot of other things to keep in mind as you move forward with that, such as what is the processing capability of your mirror. Typically, if you're going to have a mirror, you want to be able to match the processing power of your production server. But we'll get into some more scenarios going forward. And then third, improves the availability during upgrades. So another benefit with mirroring is you could use your backup mirror server as your actual production server while you're doing upgrades to your typical production server. Then once that's complete, you can switch those roles back. They refer to this as a rolling upgrade, right? Where you roll through your various servers as you're doing the upgrades, sequentially upgrading them. One thing to note, however, system databases cannot be mirrored. So that means your master, your MSDB, your tempDB, which I can't imagine why you would want to mirror that, your model, and then any of your replication databases, such as your distribution database. All those are considered system databases, and if you attempt to mirror those, you will get an error. That's not supported. But here, let's jump into a mirroring overview. I've got my principal server, some DB, I'll call it DB_1. Mirroring it means I've created a second instance, typically on another physical box in another physical location, where my information is being copied as the transactions occur to that second instance. I'm actually using the log file. So I'm taking the information from the logs and applying it to the other server. So I've got data flowing, whether it be synchronously or asynchronously, from my principal server to some mirrored server. Now, in the event that my primary server goes offline, whether it's intentionally, a planned outage, or something goes wrong catastrophically, I can then move my processing from my primary server to my mirror. Now, we'll look at different methods and different ways of doing that, but the bottom line is you get your clients up and running again as quickly as possible. Now, let's look at another possible scenario. I've got my primary database, I've got my mirror database, and data is still flowing between the two of them, but now I'm going to add a third box known as a witness server, another instance that is involved now in my mirroring scenario. This is required if I want to do what's known as automatic failover with mirroring. With automatic failover, provided that the mirror can still reach the witness and both of them have lost communication with the primary, the witness can trigger an automatic failover from the production database, the primary database, to the mirror database. And your clients are configured up front to automatically move to the mirror in the event that they lose communication with the production server. It's a pretty cool scenario. Operating modes, two are supported. It's simply synchronous and asynchronous, but it equates to a high safety mode, which under high safety mode, changes are committed on both servers. You pay a price if you think about it. Your performance is going to take a hit if you're updating not one but two databases for every change that's made. And if you're doing this in high safety mode or synchronous operation, your clients will not be able to proceed until both databases, your production and your mirror, have been updated. In high performance mode, which is your asynchronous operation, your clients are only waiting for your primary database to respond. Changes that are being sent to the mirror, those happen separately without any necessary feedback to the primary. So the principal does not wait for an acknowledgement from the mirror. The mirror may or may not keep up with the log records sent by the principal server. So you don't necessarily have to have a lag time when you're doing high performance, but you're not guaranteed that every change that's occurred on the primary is available at the mirror at the same time, right? It depends on the workload, it depends on the performance capabilities of your servers. Let's look at our mirroring roles again. First of all, we have a principal database, so your production database. This will be under a server instance that serves the database to clients. Next, we have our mirror database, which is under a second instance that acts as a warm or a hot standby server, once again depending on whether or not it's synchronous or asynchronous. And then third, we have our witness server, which is optional. This is what you'll have to have, however, if you want to run in high safety mode with automatic failover. If you're in automatic failover, it requires your third server instance known as a witness. One other thing to notice about this page. My top bullet point says principal database. My second one says mirror database. The third one says witness server. And that's because when you're looking at mirroring, you're really looking at it on a database by database case. You're not looking at the entire server. So I could have 5 different databases running on a server, and only one of them is involved in a mirroring session. Or perhaps I could have 2 or 3 of them in mirroring sessions, but each session is actually completely separate from the others. All right? But the witness itself is a server responsibility. And then last, the mirror server will initiate your automatic failover, but only if the mirror and the witness remain connected to each other after both of them have lost connection or been disconnected from the principal server. So let's start getting into some of the details of what I need to do to build this and make it fly. First of all, any service that runs under Windows always has an account associated with it. That's nothing new. When you're dealing with mirroring, however, there's some rules you want to follow with your various server instances. When you're connecting the two instances, the mirror and the principal, what gets authenticated is the service account of the engine itself, the SQL Server Engine service account. So for 2 server instances to communicate in a database mirroring session, the login account of each instance requires access to the other instance. Each login account requires connection permission to the database mirroring endpoint of the other instance. Now that's a lot of words, but actually implementing it, there's a simple way to make it work, which is the recommended way that we're going to look at. And here it is. You typically want to run each instance, the principal and the mirror, on a domain account and have them both use the same account. So in my case, I have a domain called Mel's domain, and I've created a user account, SQL Server Engine, that each instance is running under. This is the recommended approach when using mirroring. There are other options which are beyond the scope of this course if you're in a situation where you simply cannot do that. But the optimal and the recommended approach is a single account, a single domain account, and every server instance use that account. So let's get started with actually making this thing fly. So we're going to move over to our server and we're going to set up the server engine service accounts. So let's start by knocking out some background stuff. First of all my boxes need to be part of the same domain. Now a couple of them, well, one's the domain controller and another one I've already added, but I want to walk you through at least one of those. So if I go to computer, right click, go to properties, and you can see here it's only part of a work group. Go to change settings, tell it domain, give it the name of my domain. Click OK, should prompt me for a login. Click OK, and it will require a reboot. There it goes. Welcome to Mel's domain.local domain. Welcome, yeah. Click OK. Prompting for that reboot again. Click close. Go ahead and click restart. And I'll see you as soon as the reboot is done. All right, we're back from our reboot. I go start, right click on computer, properties, and I can see I'm in Mel's domain, so we're good to go there. You'll want to repeat that same process on the mirror, of course. My other mirror is already joined, but it's the exact same process. Now the other thing you'll need to do is every instance of SQL Server that's part of this, the primary and the mirror, every instance of the engine should be running on the same domain account. You don't absolutely have to do it that way, but that is the recommended way. It actually takes care of several of the security issues that are part of mirroring by simply using the same domain account for every instance. So here, let's move over to my domain server and see what I have over there. So if I go to Start, Administrative Tools, Users and Computers, and I've already created the account actually. I've created an account that I'm calling SQL Server Engine. If I double click that, you can see it's already a member of domain admins, domain users, and enterprise admin. So I basically made it look like an administrator type of an account. So that's good to go. Close that down. Let's move back over to the principal, and we want to make that account the account that is used by the engine. So here on the principal, go Start, we go to All Programs, SQL Server, Configuration Tools, bring up the Configuration Manager, and SQL Server Services. If I double click there, I can see the services I have installed, and the very first one at the top of the list is the SQL Server engine itself, or simply it's called SQL Server, and the default instance name is simply MS SQL Server. It's running, and it is running on a local administrator account. So we want to change that. If I double click, here I can enter a new name, but I'm going to browse for that. And it's not local, so click on Locations, log in using my domain administrator account. Select it on the list, click OK. If I click Advanced and Find Now, I can get a list of accounts available. That way I can just select it. SQL Server Engine right there. Click OK. OK again. Give it the same password I used when I created the account. Click Apply. When I do that, it says, hey, I have to restart the service to make this change. That's fine. Go ahead and click Yes to that. And there, once the change is complete, go ahead and click OK. And you can see I'm running now under that new account. One other thing to note, now I assume anybody following along is not in a production environment. You definitely want to make sure there's no activity happening on your server when you do that, right? Because I just basically killed SQL Server and restarted it. So I had nothing else running, so it's not a problem. So that's done. And I want to make sure you do the same thing on both the principal and the mirror. I've already taken care of my mirror, as well as on my witness. My witness is already taken care of. So now I have all three boxes in the same domain. It just so happens in my case my witness and my domain controller are the same, and all three instances of SQL Server are using the same account for the engine. So all the background stuff is done. Database mirroring occurs within a session. So what's the significance of that? It means a particular server instance can act as a principal for one database and as the mirror for another database. Now, when I buy that second server to act as my mirror, instead of having it sit idle all the time, I can actually involve it as the principal for a different database so that all of my hardware resources are being utilized. So in this particular scenario, each server instance is involved in two mirroring sessions. In one session, it's acting as the principal or the production database, and in the second session, it's acting as the mirror. Now, one thing to keep in mind if you choose to implement this, which you typically will, is that make sure your servers have the capability of performing in the event it becomes the principal for both databases. The other alternative, however, is to be prepared for a production hit in the event that you have to fail over to one instance. And then moving on to database mirroring endpoints. Your endpoint is an SQL Server object that simply enables SQL Server to communicate over the network. For database mirroring, a server instance requires its own dedicated database mirroring endpoint, and you will only have one per instance. Every mirroring session on that server will use the same endpoint. This is a special purpose endpoint used exclusively for receiving database mirroring connections from other server instances. Your client connections to your principal server will not use the same mirroring endpoint. Each mirroring endpoint is going to listen on a unique TCP port number. Now, the database mirroring endpoint of a server instance controls the port on which that instance listens for database mirroring messages from your server instances. Now, that's a lot of words, but the actual configuration is not really that complicated. Here, I'm showing the statement you could use for setting up your endpoint for your principal server. And actually, it looks exactly the same as what you would use for your mirrored server, because in both cases, their role is simply partner. Now I have in there a listener port equals 7022. There's nothing magical about that number. They just need to match. The actual default value with SQL Server 2008 is actually 5022, and that's what I'm going to stick with. If you're using a witness, you will have to also create an endpoint on the witness, giving it the same port number. The only thing different, notice the role there is simply witness. Now, I'm going to actually do all of this using a GUI. You could actually type this in, but I'm going to use the Management Studio interface and create our endpoints. Before we do that, let's talk a little bit about role switching. First of all, to support automatic failover, you have to have a witness. So in the presence of a witness, high safety mode supports automatic failover to your mirrored server. Now, automatic failover can only occur, however, if you have lost the principal server and the witness and the mirror are still connected to each other. So those two will still have to be in communication. With manual failover, high safety mode does support a manual failover. Whenever the database is synchronized, the database owner can initiate a manual failover. Now, you typically would use this for administrative purposes, such as the rolling upgrades we talked about before. Allows you to, say, upgrade your mirror first, then do a manual failover, making your mirror the principal, and then upgrade the original production server. When you're done, you can switch those back, once again as a manual failover. And then the third option is forced service or force service. You can force the service over to your mirrored instance, making it your principal, in high safety mode when you do not have a witness set, or in high performance mode. In this case, your mirror is not necessarily synchronized, so you will possibly lose data. So let's move over to my virtual server and we're going to configure our endpoints and actually start mirroring. I'm going to do it all using the Management Studio, so creating the endpoints is actually just part of the interface. And now continuing on, I need to create a backup of my principal database. When you make the backup, you want to place the file. I'll go ahead and log into Management Studio. You want to place the file somewhere where it's accessible to the mirror, or either that or you have to manually copy the file to the mirror. In either case, you'll have to restore that backup over on the mirror. In my case, the file is small enough, I'm just going to grab it and copy it over there. But do what makes sense based on your environment. Click Connect. Go to my Veronica's database, right click, go to Task, just a regular backup. One thing I am going to do different, first of all, I'm going to do a full, and I'm going to tell it to overwrite any existing backups. It'll make it a little easier when I go to restore on the other side. Click OK. And now right click, go back to Task a second time, go to backup a second time. This time specifically tell it I want the transaction log only. Make sure I get it. Now in my case, there's nothing happening in this database right now, so there really isn't a whole lot in the transaction log, but typically you want to make sure you have both of those. So that's done. Now you need to get that file physically over to the other server. So now, like I said, the way I'm doing it is just appropriate for this environment. I'm just going to physically grab the file and copy it over to the other side. Where is it? Program Files, SQL Server, Server folder, backup, and there's the file. I'll right click on that and copy it. Now moving over to my mirror, go to the same location since the default location. I don't have to navigate later on. Program Files, SQL Server, go to my server folder, navigate to the backup folder again, and I'm going to paste that file right in. And now I've copied my file over to my physical server. I can actually start a restore. Go Start, bring up Management Studio, logging into my local server. Right click on Databases, Restore Database. Give it a name. Make sure the names match. That's important. Tell it where to grab the physical file from. Add Veronica's that back. What do I want from that? Everything in my case. And go to Options. Here's an important step. You'll want to leave your restored database in the no recovery mode. In essence, you're saying you have more files to restore in a sense, but in actuality what you're restoring is the data that's coming over as part of the mirror. So click OK. Restore successful. And my Veronica's database is up in the no recovery mode. Now, moving back over to the principal, we can complete the process. So here, back on my principal, I'll close all this down. I'm on my principal server. Right click on Veronica's again, go to Tasks, and this time we're going to go to Mirror. Configuring the security is the main event that we want to walk through at this point. So click Next. Do I want to include a witness server? Once again, a witness server helps with auto failover in the event that the primary or the principal goes offline. If the witness cannot reach the principal, it will automatically start the failover to the secondary server. So we are going to use a witness. Click Next. Which servers am I going to configure at this point? I'm going to do all of them. Those are the first two. The principal and the mirror, you don't even have a choice, which makes sense. Click Next, and now it's asking me to identify each server. It's assuming the current box is the principal, and that's correct. Click Next. Now, who's my mirror? My mirror is my O1 box. I have to actually log in. I'm using Windows authentication, so simply clicking Connect will do it for me. Click Next. It does the same thing for the witness. So you'll want to find the witness server. If it's not in your drop-down, just find that on the network or type it in. Same thing. I'm using Windows authentication. Go ahead and click Connect. So I've identified all three servers. So on this screen is where we would enter our service accounts if we need to. In my case, I don't have to because I've already said I'm going to use the same domain account for all my instances of SQL Server. So the wizard will simply take that same account and use it for all the servers. So you want to leave these blank in this case. Click Next. Gives me a final checklist. Click Finish. It configured my endpoints, so that's good. Successfully configured them. And now all I need to do is start mirroring by clicking on the Start Mirroring. And now any transaction that happens on my principal server is automatically duplicated over onto my mirror server in high safety mode, which means I have a witness server that's helping to monitor the process and allows automatic failover. Looking at recommendations and restrictions. First of all, the two servers involved should be comparable systems that can handle identical workloads at least. And here's why. Well, of course, your mirror could at any point become your production box, but if you're getting into a situation where you have each server being used as a production server and then each server being used as a mirror for its partner, now at any given moment in time, one of those servers could be handling the workload of both. So you will definitely want to keep that in mind when you're selecting hardware for mirroring implementation. Next, if possible, the path, including the drive letter of the mirror database, should be identical to the path of the principal. Administration and setup is a lot easier if the two boxes are identical right down to the drive letters, the paths, everything. If not, you will have some other configuration hurdles to leap through. So you will make your life so much easier if you simply set them up as identical mirrored boxes. Next, all of the server instances in a mirror session should use the same collation, right? Determines how they compare information. Any differences between the collation will cause the mirroring setup to fail. So this is a requirement that they have the same collation. You can have a maximum of 10 databases per server instance that are mirrored, so keep that in mind in your planning. And of course, your hardware will have to be adjusted if you decide to go that high. Database mirroring works with the full recovery model, which makes sense, right? The only other two choices are your bulk logged or simple, neither one of which are going to give you any decent backup and restore capability. So mirroring is meant to be paired with your most robust recovery model. If you're wanting to use file stream, you have then decided you will not be using mirroring because mirroring is not supported if you're implementing a file stream column in any of your databases. And as I've mentioned before, your system databases, such as your master, your model, your MSDB, your temp, or any of your replication databases, those cannot be mirrored. So what did we cover? First of all, we looked at the various operating modes for mirroring. Basically, there was synchronous and asynchronous, and we talked about synchronous with automatic failover. We looked at the three roles that you can have in a mirroring paradigm. At a minimum, you'll have a principal or your production server, and we have a mirror. Then optionally, you can have a witness server, which facilitates your automatic failover. Third, we talked about mirroring sessions and how every mirror and principal relationship is considered a separate session. Fourth, I talked about the service account that's going to be used for SQL Server's engine service and how it's beneficial and recommended that all servers involved in a mirroring session, all the server engine services should use the same account, typically a domain account. Next, we talked about endpoints and how endpoints are the object used for mirroring communication. And then we just talked about some recommendations when you're working with mirroring. Well, that brings us to the end of this video. Thank you so much for watching, and I look forward to seeing you in the next video.